So this is where you're doing your slope.
So what I want to do is figure out what the shape is and then find its perimeter. So the easiest way to do that, a lot of times, well, slopes will help us to tell, hey, we know they're going to be parallelograms. They have to be, but it's not going to help us with distances. So what we need to do is we need to figure out the distances between each of the four sets of points. Now remember, distance formula is just the long-winded version of the Pythagorean theorem. So what I want to do with these things, and we did this before as well, is I'm going to do a rough sketch of it, and then I'm going to create right triangles to measure sides. Okay? It's a skill that we've done before. It does not need to be on graph paper to do that, because you can count. It's asking a lot. -4 and 2. Zero and 3. 1 and -1. -3 and -2. Everybody okay with that? So what we want to do is figure out distances between 2 points. So what happens here to get from this point to this point, you had to go vertically up 1, and you went right 1, 2, 3, 4. Which means this distance is, well, what's 1 squared?
1.
What's 4 squared?
2.
What's 1 plus 16?
17.
So this would be the square root of 17.
Oh, yeah.
Remember doing that? You're doing Pythagorean theorem real quick, okay? Because that really is distance formula. You do it again. Going from here to here,
Go over 1 down.
so we had to go over 1 again,
Down.
and we went down 1, 2, 3, 4. Oh, so it's the same thing, so it's still going to be the square root of 17. Here I had to go down 1, and I went over 1, 2, 3, 4 again. Oh,
Square root of 17.
it's the square root of 17. Hey, what do you think this is going to wind up being?
Square root of 17.
Well, it could be a square,
1 and 4.
or it could be a rectangle, so we have to check slopes then too.
Over 1.
So we go up, we went over,
1.
and we went up 4, so all of our side lengths are square root of 17. So that means it's either going to be a rhombus or a square.
It's a rhombus.
Why can't it be a rectangle? Oh, I misspoke. I meant to say square. So what we need to do now is to tell whether or not it's going to be a square or a rhombus is to see if you've got right angles. If you've got right angles, that means your slopes are what? Nope. Well, they have to be, but what do you find with slopes? Remember, slopes, if they are, no, I already said that. So if they're parallel, the slopes are equal. If they're perpendicular, they were opposite reciprocals. You might want to write this down, because this is stuff that parallel slopes are same. Okay. Bless you. So, remember when you're talking about slopes. Slopes is rise over run. Since you have a rough sketch of this, if you think about it, you've kind of already filled in what your slopes are. To go from J to K, we went up 1 over 4. So my slope between J and K was up 1 over 4. The next one, from K to L, well, I went down 4 over 1. When you go down, it's negative. Are those two opposite reciprocals? Which means right here is a right angle. Then you check it going to the next one. Now, when you have lines, slopes are positive if it's going up and right. Slopes are negative if they're going down and right. Remember that? So from back to here, I had to go up 1 over 4. So the next one is 1/4. This one was down 4 over 1. So are these, is this a rhombus or a square? It's a square. Okay. You get a square out of that. It takes a minute or two to go through something like this. Maybe one of the things that you guys could do is when you see something like that, is know that you have to find 4 slopes. And write down that you have to find 4 slopes. Too many of you guys are still flipping your slopes around. It's y over x, changing y, rise over run. Okay? Gotta remember that. Let's try the other one. Same deal. What I want you to think of is that you need to find the distance between all of them, and you're going to find the slopes between all of them. Whether or not you want to list them and go through the long way of doing it, or to start piecemealing it together, which is fine. Remember, when you graph these, as you're figuring out your rises and runs, that those are the side lengths of the right triangles that you're using to figure out the hypotenuse. It's a real quick thing to do. Also, one thing you might notice, I'll show you that later. So let's piecemeal it together again. J7 and 2. -2, -3. -11. Yeah, do you mind? Thanks. Okay. Oh, we forgot to find the perimeter of that one. If you have 4 sides of the square root of 17, what would the perimeter be? That's all it is. Yeah. Since you all 4 sides, I forgot about the side lengths on that one with the square. To find the perimeter, just add up all the sides. Well, bless you. Well, if you have 4 sides of the square root of 17, it's just 4 root 17. 4 times the square root of 17 is all it is. So go through the same deal. Figure out your distances by walking it. We're at 2. We had to go to 7. So you have to go up how many?
5.
And you are at -11, and you have to go to -2. You want over 9. So that distance then, 81 and 25, and you get, what is that, 106, I believe?
Something like that.
So we'll just call it the square root of 106. Now, do you need to simplify those, well, like simplified radical form? If you want, I mean, I think your calculator will do it for you automatically. All right, if you do, 5 squared plus 9 squared, and you take the square root, it will simplify it for you. I don't believe that simplifies because you get 4 won't work. I don't think that's simple. I think it just stays at root 106 if I'm not mistaken. So We are. So now you also know that you have the slope then right away of from M to J. The slope, you went up 5 over 9. So you know that right off the bat. Going from J to K, well, you started at -2, you wound up at 7, so how far is that? -2 to 7? 9. And then from 7 to 2 is 5. So it's another root 106. The slope is going down and to the right, so the slope between those two is the opposite reciprocal. So you do have a right angle again here. Okay, you have a right angle. So what is that, J to K? Oh wait, that's not an opposite reciprocal, is it? If I go down 5 over 9, that's just a negative slope, isn't it? That's a tricky one, isn't it? All right. Well, if we know that it's not going to be a right angle here, we know it's not going to be a square or a rectangle. It could be either a parallelogram or it could be a rhombus, depending upon what our next point tells us. I mean, in the next, actually, our next one could tell us if it's a kite, but we don't know that yet. We'll learn. We'll talk about that tomorrow. So what are we at? We're at 2, and we got to get to -3. So that's another 5, and isn't this back over 9? So here's another root 106. With the slope of up 5 over 9. So these two sides are parallel, and they're congruent. Well, hey, I bet you this is down 5 and over 9, which gives you another root 106, which means this is a rhombus. Okay. You get a rhombus out of this one. All right. Your opposite slopes will be parallel. Your opposite sides are, all 4 sides are the same. So then to figure out the perimeter, you just add up, you just add up the 4 sides. Well, root 106, root 106, root 106, root 106 will add up to be 4 times the root 106. And that's all that is. Yes, sir? A kite is, it's a quadrilateral with no sets of parallel sides, with two non-opposite sides congruent. So 2 adjacent sides congruent. What that means is that you have basically an isosceles triangle with another isosceles triangle. Okay. The diagonals then, we'll talk about this tomorrow, the diagonals are perpendicular. And since this is an isosceles triangle, this stuff happens here. These two angles become congruent, and these parts are bisected. And we'll talk all about that tomorrow. All right, we'll get more into that. Okay. Just wanted to show you guys some coordinate fun stuff.
A is 5. B is 9. 5 squared.
Do that? I saw something going around the corner behind me.
Ladies and gentlemen,
If I were to
oh, you're welcome. You're welcome.
That's the funny thing about that, man. They can't try to play.
Yeah.
The way you did that. You looked over, stacked together.
All right, so what I have for you guys here is a mixture of a worksheet again.
said thank you. I said thank you.
What?
Do those, please. Okay, do those, please. I will give you a quick hint. Oh, I was gonna walk back around and hand you guys those. I'm gonna give you guys a hint. I want you to look at number 15 on the C side. Number 15 tells you that you have W, X, Y, Z is a rhombus. But what don't you see?
Picture.
A picture.
What was it?
W, X, Y, Z. If it's a rhombus, we know basically that. It tells you the angles. Angle X is 24 times 10 minus X. Angle Z is 6 times X plus 15.
You set those equal to each other.
You set those equal to each other.
Subtract by 1.
And then you subtract it from, after you solve for X, you figure out the angle, and then go from there. Because you're trying to figure out what angle Y is. So what you're gonna do is you'll set those two equal to each other, solve for X, and figure out what the actual angle measurement is. Because you know that consecutive interior angles are always supplementary, so if you figure out what angle X is or angle Z, the supplement would be angle Y. For those types of problems, you always want to draw a picture, that way you know what parts you're working with, whether or not they're going to be equal, supplementary, things like that, all right? We should be able to, you guys should be able to fly right through that. And we'll talk about heights and trapezoids and things tomorrow. Okay? You got time to work? Let's go. Did you guys have a bunch of spares on that? I'm assuming. Lord knows I just don't like to count. There might be money here still. No, that's fine. Bless you. Actually, probably. Oops.